on. And hi everyone, welcome to this 20th Urban AI conversation. It's a great pleasure of welcoming you today. My name is Hubert. I'm the founder and director of Urban AI. So what is Urban AI? It's a global organization dedicated to the emerging field of urban artificial intelligence. We are a think tank with which we are doing open research experiment in this field. We also federate a growing and global community of 200 experts working or doing research at the intersection of AI and cities, a community to which Daphné Tapia, who will be your moderator and host today, is part. And lastly, we recently launched a consulting branch to help urban organizations in their urban AI strategy and policy. Regarding this urban AI conversation that is dedicated to AI, remote sensing and urban sustainability, it will be moderated by Daphné Tapia, who is a member of the urban AI community, also director of business development at ImiSight and an international expert on remote sensing and satellite image data. You will first have presentations from our speakers that Daphné will present you, and then we will have Q&A session at the end of this conversation. So if you have any questions, any remarks, please feel free to share it in the chat, and we will ask them to the panelists at the end of this conversation. Daphné, the floor is all yours.
Thank you, Hubert. Hey, everybody. Nice to meet you. Again, I'm Daphné. I'm the moderator of today's discussion and also a member of Urban AI for the past 2 years, I think. I've been working in the field of GIS and remote sensing for the past 7 years, and today I focus mostly on AI and machine learning algorithms to detect different objects and changes on satellite imagery for environmental and urban monitoring. And before giving the floor to our 3 amazing panelists, I'll share with you a brief introduction about the state of the art of AI and remote sensing in the field of urban sustainability. Then again, our 3 panelists will have 8 minutes each to introduce themselves and their projects. And finally, we will have a 15 minutes discussion about the challenges and opportunities they see in the field. So very quickly, I'll go over these few slides. Why do cities need eye from space? So you're not without knowing that urban areas face unprecedented challenges, aging infrastructure, for instance, water pipes. In many US and European cities, water pipes are over 100 years old, and Jacquie Matzkin will tell us all about that in today's discussion. Then there is the topic of infrastructure or terrain that can be subject to movements, and that's Fifamè Koudogbo expertise, and she will share with us all about it today. And finally, we can also mention climate change and the urban heat island phenomena that are issues that will be addressed by Brian Killough today. And all these challenges bring us to the topic of, remote sensing that provides large-scale images, high frequency of image acquisitions, and free data even sometimes, and most of all, objective views of cities. And multiple data sources are available: optical imagery, radar imagery, thermal imagery. And our panelists today will dig into these specific options to understand how AI can contribute to urban sustainability. So I'm very happy to introduce, first of all, Brian Killough, ex-NASA and satellite data and application consultant at Ernst & Young. Then Jacquie Matzkin, Director of Product at ASTERRA, a leading company in pulsar application. And finally, Fifamè Koudogbo, expert in Earth observation and InSAR technology at Sixense. Brian, the floor is yours. Very excited to hear your presentation.
All right. Can everybody see the slide?
Yes.
All right, fantastic. Thank you, Daphne. Appreciate the intro. Looking forward to the conversation and all the speakers today. So my name is Brian Killough. I have been with EY for 2.5 years. Prior to that, I had a long career at NASA for 35 years working on remote sensing and satellite data with many international space agencies around the world. Had an opportunity to see a number of issues solved by satellite data. And when I came to EY, I got involved in a data challenge, which my passion, of course, is satellite data. So we've infused satellite data into these data challenges. So let me tell you a little bit about what we're doing this year on the topic of urban sustainability. So we do a data challenge at EY for a few reasons. Number one is AI for good. We're trying to every year cycle through the Sustainable Development Goals with the intent of showing that you can apply AI, data science, machine learning to solving these problems. So bringing the attention to these problems in an AI for good manner. The second is EY branding. We obviously want the world to know that EY is positioned in this market to work with our clients to solve problems using AI and data science. And then we also have a third goal of talent, because these data challenges almost always uncover some incredible talent, people that are really good at using AI and data science to solve problems, and some of that talent ends up coming to EY. And in many cases, that talent is already out there in other companies, but it's remarkable to see what can be done. This year's challenge, we award $10,000 to the winner, so a really nice prize in the end. It's open to a demographic of young professionals, and mostly university students and young professionals. So we don't want someone with 20 years of experience to tackle our problems. What we're looking for is new people in the area, people that are really interested in learning and learning more about how to solve these problems. So we've been doing data challenges now for 5 years. And each year we've infused satellite data and remote sensing into the solution. So we started off with fires, and then we did what we call our frog challenge in the second year, which was a biodiversity challenge. Then we did rice crop monitoring in Vietnam. Last year we did high resolution data with coastal resilience, looking at storm damage. And this year, an exciting new topic of urban heat islands. And I'll tell you a bit more about it, but we've just now concluded that challenge about 2 months ago, and we're in the evaluation stage. So why urban heat islands? What is this all about? Many of you, I am sure, have experienced this. If you've walked down a city in a hot summer day, you know that in the center of the city, where there's dense buildings, lack of green space, lack of water, all of those things contribute to creating a very high heat environment. And what happens is the cities tend to trap that heat because of the situation. And knowing where those places exist, understanding what the drivers are, and then having this ability to possibly, through sustainability measures, change how we manage our cities, that gives us the opportunity to make it a better place to live. We also know that in the future, by 2050, they're suggesting that 70% of the world will live in cities. And if that's the case, we need to have a better understanding of what's happening in the cities so that we can promote a more sustainable future, and one that we can have better lifestyles. Because frankly, what happens is the high heating tends to attack the most vulnerable populations, which are the elderly and young people. So how did we do this? We used a data set this year from New York City. There's a bunch of these data sets around the world, but we chose New York City because it had a really nice diversity. There's, in the bottom left, you can see on the right-hand side, that little maze there is really a ground traverse where data was collected on the ground so that we could understand what this urban heat island effect was. The areas in red were the hotter spots. You can see in the bottom left where Central Park is, which is a green park, sort of like my background here. That is an area that's a bit cooler, so you can see the temperature differences there. And so we collected this data. There's a company called Kappa Strategies that does this, about 12,000 data samples. And if you combine that with satellite data, you combine it with building footprints, more knowledge about urban density, perhaps the heights of the buildings and some other data sets, it is possible to build a digital twin to understand, forecast, and predict where do these heat island areas exist and what are the drivers. And that's what the data challenge was all about. So once we put this data challenge out, you see in the bottom left, we had over 11,000 global participants this year. We had a really fantastic outpouring of interest in the challenge. Over the years, in the 5 challenges that we've run, we've had now 44,000 participants, 2,000 universities in 145 countries. So really an amazing interest, global interest, in solving these sustainability problems with data science, AI, machine learning. So it's exciting to see that people are interested and sustainability topics are at the forefront of what we are trying to do. So lastly, let me tell you about where is this challenge going and what does it mean for the future. So we closed the challenge on March 20. We're in the evaluation process right now, deep in the evaluation process. Matter of fact, I'm doing a few of them myself, and we have a committee of evaluators that are doing this, judges, we call them. And by May 22nd, there is a virtual awards event. If you want to check it out, you can go to my LinkedIn. I think there's some posts out there that show you how you can attend. But on May 22nd, we will virtually award the winners and 2 runners-up, and they will each get cash prizes. But the winners, both an internal, which is just EY employees, we open this challenge internally, and externally, we will take those winners to the AI for Good Global Summit in Geneva in July. So that's a real exciting event. If you don't know about it, AI for Good Global Summit brings together many people in this environment of using AI to solve sustainability problems. Our finalists right now that we're reviewing, if you look at that list of countries, it's amazing. All across the world. You've got several countries there from Asia, you've got several countries there from the Europe, and then we've got a few from the Americas, Colombia and Canada. So really what we found was our finalists come from all across the world, and it's really exciting to see the geographic diversity. So what happens in the way we run the challenge, and we've learned this over time with our legal folks internally, we leave the IP in the hands of the winners. So we, EY, are not interested in taking the IP over. We're not trying to make a commercial opportunity out of it. We want to bring attention to the problem, and we'd like them, the winners, we urge them to share their models on GitHub so that those winning solutions could then be used by beneficiaries across the world. In this particular case, the winning solution will be a digital twin. It'll be a model. And we're working with a company on the far right. You see a reference to them. The Natural Areas Conservancy is an advocacy group in New York who is advocating for green space in cities, not just in New York City, but also across that entire region. And they want to use models to get a better understanding of the city, which helps them with their advocacy because they can then model the availability and the location of green space and understand how much does that green space drive the urban heat island problem. And so we have a scientist and a researcher, one of the PhD folks at NAC that's on our review committee and is also our key beneficiary, and he's real excited to see what comes out. So that's all I had for today, just to give you a little bit of background on that data challenge, why we do it, and we're excited to see where it will go in the future. So back to you, Daphne, and our next speaker. Thank you.
Thank you, Brian. I hope this challenge can be a source of new participants for next year that never heard about it. Hopefully, you will have a lot of applicants. Thank you very much. Jacquie, please take the floor.
Okay, thank you. Let me just share my screen. Okay, so thank you. My name is Jacquie Matzkin. I'm the Director of Product at ASTERRA. I've been at ASTERRA for around 4.5 years now, and my background is in remote sensing and soil spectroscopy. Today, I'm going to talk a little bit about how ASTERRA uses AI and remote sensing technology to contribute to Sustainable Development Goal 11, which is a goal of sustainable cities and communities. We'll start with a quick video. I hope you can. So our technology, using synthetic aperture radar, was originally developed actually to find water on Mars, and then it was modified to find potable water on Earth. And the algorithm was originally built based on leaks that we ourselves manufactured in our backyards using garden hoses, because this kind of data set just wasn't in existence back about 10 years ago. And once the algorithm was built and commercialized, our database quickly started growing into what it is today, which is a database with over 200,000 data points and over 150,000 positive potable leaks. And we're able to use that to build the precise AI algorithm that we use today. So our mission is to use that power for good. I really connected to what Brian said. So we want to become humanity's eyes and guide it through Earth's changes by applying our capabilities to real-world problems. And one major real-world problem is water scarcity and non-revenue water. So the core technology uses L-band SAR satellites, synthetic aperture radar, to observe soil moisture changes from space. And the reason we use L-band is that it penetrates the surface, so we can see a leak before it ever surfaces. So we can literally see what humanity and our clients can't. And then we apply our AI-powered analysis and algorithm, which was built, like I said, based on our own empirical, robust database, and we can detect those potable water leaks. And what's so great about this remote sensing technology and analysis is that one imagery covers an entire city in one go. So, and unlike other SAR technologies, we don't need multiple imageries in order to make our analysis. Each analysis uses one imagery at a time. So we're able to give a diagnostic analysis of what's happening right now in the system. So the way that it works is an area of interest is defined. We take a satellite scan, overlay the pipes, run our algorithm, and find the leaky areas. And then our users' field crews will go out and do a field investigation in those locations where we found potential leaks. And what we're really doing is boosting our ground crews' efficiency. And we can see it very easily in the numbers. So with ASTERRA, crews will investigate about 31 miles of pipe, and without ASTERRA, about 310 miles of pipe, which is a huge difference. And though they're investigating a tenth of that pipe length, they're actually finding far more leaks in far less time. So that boost in efficiency, it's cutting back on manpower hours, on energy hours, on greenhouse gas emissions, and it's working, and we can see it in the numbers. We're working in more than 64 countries, and in every case, the result is the same. We have faster leak detection, less excavation, reduced emissions, and more resilient services for communities. and faster repairs for communities that are losing water that the leaks are not surfacing. And the cities don't need to install hardware or sensors or overhaul their IT or invest millions. They can leverage our AI and space-based insights to optimize their systems today. So ASTERRA is actually contributing to 4 of the SDGs. Today we're focusing on number 11, which is the sustainable cities and communities. And we have 3 solutions that contribute to this goal. We know first and foremost that cities start thriving from the underground up, and all of our solutions are looking underground to see where the problem areas are and where we can help our users be more resilient. So first is Recover, which is what I've been speaking about, which is our AI-based algorithm, which contributes to more efficient water resource management within cities. And it's continuously becoming more accurate and more precise as we go. We have Master Plan, which uses the same data set and enables utilities to assess and manage their pipe networks proactively, so where they need to maybe prioritize leak detection efforts or pipe replacement efforts. And this really helps with the growing population of cities that we see. And Earthworks, which is for communities that are located near mining facilities or dams and levees, we can provide an early warning and risk assessment based on underground soil moisture data. So Earthworks is contributing to ensuring the safety and water security of local populations. We know that smart cities, they're not just built with sensors and apps, they're sustained by unseen infrastructure that is below the surface, and we're able to provide information on that. So if we look deeper a little bit into SDG 11, it's broken down into a lot of different paragraphs, but I think that we are answering 4 main issues that come up there. Number 1 is inclusive, sustainable urbanization. And we're doing that by enabling cities to map vulnerabilities and act before a crisis occurs. Reducing disaster impact by detecting infrastructure failure risks early. Environmental impact reduction by cutting water loss and energy used to treat and pump water. And I think that's the biggest one that we're contributing to, in my opinion, is really cutting back that real water loss, saving the energy that is used to treat that water that's not reaching the consumer, and at the end of the day, also reducing the greenhouse gas emissions that are caused by that wasted energy. And finally, resilience planning. So we're providing data that guides proactive maintenance and climate adaptation. So that's ASTERRA and what we're doing really on one leg, as we say. Thank you. I will hand it back over.
Thank you, Jacquie. I had myself the pleasure of working at ASTERRA for almost 4 years, and I can say that it's very impressive how this company successfully built a network of partners worldwide utilizing this technology. So ASTERRA is slowly conquering the world of non-revenue water, and kudos. Thank you, Jacquie. Fifamè, your turn.
I'm sharing my screen. Can you see it? Is it fine? Okay. So thank you. I'm Fifamè. So I'm working in Sixense. I have been working in the domain of remote sensing and ground motion measurement since now almost 20 years. And joined Sixense is about 1 year ago as Earth observation application specialist, and I'm also leading the innovation team. So just a word about Sixense. We are member of the Vinci group. In the organization of Vinci, we are under the Sol Étanche Fraissinet branch that gather all the expertise on soil, structural and nuclear engineering. So we are about 850 people all around the world. The headquarters are in Paris. And we are working in different range of expertise, particularly in monitoring and digital solution for infrastructure and construction. So I will focus on this presentation on the monitoring part and the satellite-based monitoring. So in satellite, our solution for satellite-based monitoring is called Atlas InSAR. It has been developed in our satellite division that is located in Barcelona, and that will use the so-called SAR interferometry to measure ground deformation and stability of infrastructure with millimetric precision and over ledge area. So I insist on all of the terms because it makes also the difference with other methodology. I put a small drawing here so that we all know of what we are speaking. We will use the successive passes of the satellite over the same area. By processing the stack of data that we have, we are working with radar satellite, we will be able to identify what we call measurement point, that are measurement point on the radar point of view. And for all of those measurement points, we will be able to compute the displacement. The results are given as the map that you see here. The colored dots are our measurement point, and we use a visualization scale that will give us information on the orientation and dynamic of the displacement. So what is interesting also is that for all of those points, you can get the temporal evolution of the displacement. So here we see, for example, the impact of the tunneling activity of the Crossrail metro in London. So what you see here for one of those points located in the red area is the subsidence due to the tunneling activity, and then is getting back to the normal. So our client could be local authorities, concessionary, asset manager, construction company, and engineering firm. Just to summarize, the benefits are the historical analysis, the wide range of application. I put some of them here. The fact that it's a non-intrusive method and all weather because we are using satellite, radar satellite, and the platform that we are developing that is beyond monitoring. So doing that, we are also investing a lot of time in developing capabilities in AI that will allow to enhance our result, our product, the service. So the main focus area are the advanced advanced data analytics and pattern recognition. So we are using our database and playing with the results so that to extract the useful information. The automated processing and interpretation, integration with other source of data, because we try to integrate with GPS, topographic measurement, etc., and the visualization also. So I have two examples that I wanted to show you. The first one is in Auckland. So our client has a large area of interest of 450 square kilometers. And he noticed that with the climate change, the droughts that are longer, the precipitation that are higher, they were adding more and more infrastructure that have some impact. You were seeing that some damages that were visible. So they wanted to know if InSAR could help in identify the structures that are more affected. So we did a first study over 3 years with high resolution data, 3x3 meter resolution, and we got more than 9 million of measurement points over this area. So that make a lot. So what we did is we were working here with the Geological Institute that provide us some information on the standard pattern of the expensive clays, how they are evolving during the year. So we did different analysis of the data, and one of them is to identify all the pattern of the displacement of all the measurement points and to compare it with the pattern that were given to us. From this analysis, we could detect the points that were more affected by the presence of expensive soil. So, as a result, if I can show you, so you have first the point, the dot, that are the classical INSAR measurement. Here there was a small animation that doesn't work, but doesn't matter. From this analysis, we could detect with the analysis of the time series of the temporal evolution, detect how the point affected by the presence of expensive clays were located. And then the last step was to analyze the amplitude of this seasonality in the time series and to be able to give like a classification of the building depending of how much they are affected. Next step is a risk analysis and to relate it with the position, the ground, the foundation, etc. So different step on this. I will go really fast in the next one. Here we are in some high school in Paris. So the idea was to find a way to optimize the maintenance operation and to prioritize the intervention. So we did an INSAR analysis also. So you have here the result at large scale, but also the possibility to see at local scale what we have. Then we studied the different displacement, and the idea was to give a classification of each of the building based on the analysis of the time series, the knowledge of the point around, to add also external data and to be able to classify this information. So just to conclude, because I'm a bit late in this, so the using of AI in the INSAR application that we are using has for objective to improve the efficiency in risk management and urban resilience. So we are really focusing in different aspects to be able to propose a tailored monitoring system for in urban area. Thank you.
Thank you, Fifam. I know you were stressed about the time constraint, but you did amazing.
I have a lot more to say, but I did it short.
I try to give you the opportunity during the Q&A session. But thank you for your presentation. I think it's nice as well to have two experts from the SAR industry that works on completely different topics. And I hope our audience also enjoyed this diversity. Jacquie, you had a question in the chat. Would you like to, I know you wrote back, you wrote an answer, but maybe you want to specify more stuff orally?
Yeah, I think the answer is pretty straightforward. The question is if there's a minimum size or resolution for areas of interest and if it would work in cities in the Pacific Islands. So the satellites that we use, we have a suite of L-band satellites that we're able to task, and they have global coverage. And we work with networks really of all sizes. And our spatial resolution is fairly high, so there should be no resolution issue on any AOI for cities in any area. I put an email that we can be reached on for specific questions in the chat.
Thanks. Okay, so this is the moment we all waited for, the roundtable. I start with the first question. I think it's for all the panelists, so whoever volunteers. Up to you, how close are we to having satellite AI systems fully integrated into daily city operations? Brian, I know you're a consultant, you're working with a diverse range of people. Do you have any input on that?
We're getting closer. I don't think we're there quite yet. I think the biggest problem we've seen in talking with our clients is they're interested in AI, they're interested in data science, machine learning, and what the potential is for all of this, I think the adoption part is taking some time. So, and I don't know if it's sort of a lack of confidence or understanding for most of the clients and the people we deal with. They're not GIS experts, right? They don't really understand satellite data deeply like those of us on the panel here. And so a lot of times I find that I spend a lot of time educating our clients, telling them a little bit more about what's satellite data all about, how can we combine this with machine learning and cloud compute to achieve these solutions. And then you have to build some confidence in their understanding so that then they see that, yes, there is a potential here, and that we maybe need to take some data, attack a problem, learn a little bit, and understand whether this particular set of data can solve their particular problem, because everybody's problem, might be a bit different. So I think adoption is a little bit slower, and a lack of understanding. And I see Jacquie nodding her head, so I'm sure she wants to add some as well. But we're getting closer. I'm excited about the future. We're getting closer. Jacquie, you want to add some?
Yeah, I so deeply identify with what you said. I was going to say, I don't think that the gap is technical. I think the gap is absolutely institutional. And I think we're not waiting for the tech to mature. We're waiting for organizations to have the vision and the processes to be able to adopt that technology. And me personally, or what I run into often here is, it sounds like sci-fi. It sounds like some technology that would be, on Star Trek or whatever. What you can see below ground, that doesn't, no way, but actually being able to show it and demonstrate, no, this technology really works. I think that's the main gap. So I really identify with what you said, Brian.
I also tell people that most of this data was really only available in our hands in the last 10 or 15 years, right? So some of this technology, some of the new missions that we're launching just in the last couple of years, and some of this high resolution imagery, we couldn't touch any of this 5-10 years ago. And now all of a sudden we have this commercial potential to go out, task a satellite to measure where we want to measure, purchase that data and use it to solve an unbelievable problem. And then it's a matter of, what are the economics of the cost of that data and the analyses to tackle a problem. And in many cases, companies come to find out that, yes, with a little bit of investment, they can save themselves lots of money and lots of, ground going out. In your case, Jacquie, finding leak detection and surveying hundreds of miles of pipeline versus, we think there's a leak here, there's a high probability of a leak here, go to that specific area. You're saving them tons of money and time. And so these are the things that just take time for them to understand. But we're only in 10, 15 years of the data being available. The last 5 years, the AI and machine learning and cloud computing have gotten so much better. So we're in a good state now where all this is kind of coming together to unlock some real great potential, and all the speakers here kind of showed some of that.
Yes, just if I can just add, I think we were answering to the second question also, and I think it's really important to speak of the awareness. And this is a lot of work, I will say, in our activities, and also the budget constraint, because it works together. They don't believe, but they are not ready also to invest and to try something that you don't believe and you didn't see. So we spend a lot of time to try to explain that it works, that and how it could be a big benefit. So totally agree.
Opportunities like this one, webinars, roundtable, it's a good way to educate the market, the people. By the way, I'm interested to know if among the attendees, some of you are working in municipalities or are engineers. Are you considering using satellite imagery or not? Just leave a word in the chat. It would be cool to know. I have another question, again, for whoever feels inspired by the question about AI explainability. How do you make sure that the results from your systems are interpretable and trusted by the city managers, by the engineers? Yeah.
I can start if that's okay. So specifically at ASTERRA, as I mentioned, it's very easy for us to explain because our whole database is ours. And every single point of data is validated by a team that we know and we trust. So in a sense of, AI as a kind of a black box, for us, it's a clear box. We know what's going into it. And in terms of the interpretability of it, I, as director of product, I prioritize providing the data and the insights to the client in a way that they can use it and interpret it, as opposed to this is how I think that it should look, or this is what I'm telling you that it is. Because if it's seen as uninterpretable or unusable by the end user, then it is. It's useless. So I think that for us, that's the combination. We have full confidence in the data that we're using because, again, it's ours, and we actually have the largest leak database in the world, and we know it. As well as the largest commercial consumer of L-band data in the world. So we know we trust our data, and then prioritizing the presentation of that data and the presentation to the end user in a way that fits their needs, as opposed to a way that I think would fit my needs.
Thank you. Also, I think in terms of trustability, your customer either find the leak or don't find it, and it's very easy to count and to make the metrics about that. Cool.
Yeah.
Fifam, any input?
Yes, what I can say is that we are delivering insight to our customer with some precision, QC, etc. The AI come after. It's like a post product that usually we develop based on requirements that are coming from our client. So when we put AI, it's often a development that is done with the client in close collaboration. So we extract metrics, indicator, they validate, and also InSAR give the possibility to go back in the past. So usually you have also an historic, an inventory of damage, event, etc. that you can compare and see how. So always what we do is to get at the end some metrics, indicator that we know can be used depending of the client, the end user, its profile. Is it a GIS people, IT, one that is taking decisions at the end? So, and we have always to play with them so that to be able to deliver the most usable and trustable product.
Thank you, Fifam. Brian?
So, and when I work with clients, I think the thing that strikes me we try to do the most is to get them involved as early as possible and try to be transparent about the data we're using and the intermediate solutions we're getting and how we're doing this whole AI process. So I think, Jacquie, you said, you referred to it as sometimes it's a black box, but you don't want it to be that. And so the more we can teach and educate the people that we're trying to, sell this to a client, in my particular case, we have to educate them on what does this data look like? How is the AI acting on it? What these solutions, so that they can gain confidence. But it's all about this transparency and the education, because in many cases it is complex data. The AI processes and machine learning and so these algorithms we're applying, they can get really complex and crazy, but it's not for them to understand that so much as what does the data look like? What do these intermediate solutions look like? And are we solving their problems? So it's this process that we try to take them along the journey, because I think if we just treat it as a black box and say, well, give me your data and I'll give you the answer, I don't think that goes well. And so we try to get them involved.
Thanks. Brian, I'd like to stick with you for a minute. I know you're very involved in the field of open source, and you were involved in the Open Data Cube opportunity. Can you say a word about it? You also mentioned GitHub during your presentation.
Yeah. So I am a firm believer that open source software and the open source community is something that will help us progress faster into the future, right? If all of us develop algorithms and AI and techniques and we don't share among each other, yes, maybe someone has a small commercial advantage, but I don't think they're going to advance as fast. So back when I was working at NASA, I started a program called the Open Data Cube, where we knew that satellite data was being put out by satellite agencies around the world in a lot of different disparate organizational methods, and the data was hard to access, just hard to utilize. And so we took this idea of this Open Data Cube community, but we did it with an open source mindset so that we would all share, we get contributions from others. So open source has kind of twofold advantages. One is that you get people contributing. They're willing to contribute and willing to be part of a community, which then grows and advances things. And then there's just the general sharing for someone that may not be involved in the community, but they can come to a GitHub, and a GitHub is a site where people share their code and share their ideas. Well, people could just come in. Let's say I'm doing an urban heat island model, and one of our data challenge winners decides to put, which we hope they do, put their solution out on GitHub. Any city could come there, a city AI specialist or GIS specialist, see what this person has done and maybe utilize that solution to help improve their city. Well, how else would they get to that, right? If we didn't have open source software, didn't have an open source community, all of these great ideas just get lost. So I love the open source community. I think it's fantastic. And the more we have of this, I think the faster we advance in all of this.
Amen. I'd like to think that too. Jacquie, Fifamè, I don't want to trick you with this question because I think you're not working or contributing to the open source area, but feel free to say a word if you want. You're not unmuting yourself, so you're not. So a question for you, Jacquie and Fifamè. You're both working in the SAR industry. What are the limitations? What are the improvements to come? What are you excited about SAR? And how are you using it to enhance urban application? Fifamè, maybe?
Yes, should I try? So I will say, if we speak of SAR in urban area, I will say the main limitation that we are waiting to get more satellite, things are coming anyway, is to have a better spatial and temporal resolution, perhaps the use of other parameter characteristic of satellite data, the polarization, etc. So without going too much in the detail, I will say we have some limitation in monitoring fast motion. So sudden motion, if we succeed to get fast repeat, revisit of the satellite, faster imagery, we could get something really interesting. On the AI side, we are working also on how reduce the noise of the system and to be able to detect small motion, subtle motion that sometimes are interesting and that for now we still struggle to know if it's a real motion or noise. And so on all these, there is still a lot to do. So we are busy on those applications. And we are looking also on the new satellite coming to see, and waiting a lot also perhaps from the nano satellite, seeing the onboard processing. There is things that could be done also to get closer to near real-time analysis. But I don't know if we speak of 5 years, 10 years, but let's see.
Thank you. Yeah.
I wholeheartedly agree. I also wrote down the point, you know, better resolution, better frequency, and smarter fusion, I guess, into existing systems. I'd also say that, you know, the bubble hasn't yet burst on SAR satellites, especially with L-band. So we're waiting for more commercial SAR satellites, more commercial L-band SAR satellites. I think that, you know, they're coming and they're starting to go up, and a lot of the new ones that are going up in the next 5 years, by the way, are planned to be open source, which is very exciting, I think, because it just provides more accessibility and consistency in the data. So I think that the improvements are starting to happen. It's just a matter of time.
Yeah, and the more satellite, the more data, the cheaper as well. So
absolutely, absolutely, yeah. Right now, price is definitely a limitation, especially with what we're working with, because there's so few, if any, really commercial L-band SAR satellites, and even the commercial C or X-band data ends up being expensive simply because there's not as much of it as there should be, or as there could be.
I feel that we're closing the loop with what we mentioned at the beginning with the financial limitations. So hopefully in the next few years, it will be even more open to a larger public. We started mentioning it a little bit, but Fifam, you mentioned the nano satellites, more satellites coming. Are there any other exciting trends of the future that you'd like to mention about AI, remote sensing? Are you excited about anything specific? Brian, maybe?
Yeah, I've got a few ideas on that. Hyperspectral imaging, I think that's a biggie. Like when they start to figure that out, and Jacquie agrees with me, that is going to open up a whole new gamut of applications and ways to use this data. We're even seeing this at NASA, like the next generation of Landsat, they're talking about expanding the number of bands. So not quite going hyperspectral, but significantly more bands, which, you know, gets you closer and closer to the hyperspectral. So hyperspectral is one. The other one that Jacquie, you sort of alluded to, is just having more of these radar missions out there. And if we get more of them, so the different bands, C-band, X-band, L-band, you know, NISAR is coming up now, and NASA's going to have the L-band out there. That's going to be free and open. How can we possibly use that? So you've got, if we get more of the missions out there, that creates global competition, which will then lower those prices quite significantly. And we won't have to be paying $100 per square kilometer for some of this expensive radar data. It'll just get a little bit more commercially available to all of us. And I'm okay with there still being a commercial aspect to this, right? I'm not expecting some of these radar missions to be free or hyperspectral to be free, because in the beginning they're going to be very costly to create these missions. But if we can get those prices down so that, you know, the rest of us can use it more functionally and it not be cost prohibitive, then that's exciting. That's really exciting. Oh, and the cloud computing piece, by the way, it just seems like every couple years we, you know, increase our capabilities to, you know, by an order of magnitude. So I can't imagine like what cloud computing is going to look like 5 years from now, right? It's just we're going to be doing things so fast and so amazingly quick, and we'll be just doing them on our laptops like we were years ago. So that's going to be another big advantage.
I'm not an expert on the topic, but I recently read something about the quantum sensing and how everything will become super fast in terms of computation. So maybe you're also referring to that.
Yeah, quantum compute, is that what you're saying?
Yeah.
Yeah. Quantum compute it's getting closer, no doubt. That's probably the next phase of where we're going. I mean, we just kind of started this AI journey, but everybody talks about the quantum compute. It'll be here.
Okay, it's all sci-fi.
Yeah.
That's
right. Then we're going to have to explain it to our clients. They're going to say, "What's this quantum computing? I don't understand." That way, we have to explain it to them.
Yeah, it's going to be on YouTube, so you have to have an answer ready.
Indeed.
We have 4 minutes left. If anybody among the attendees have a question, please write it in the chat. Otherwise, I will give the panelists the chance to conclude. And maybe if we have any city planners or engineers, etc., do you have any recommendation for them to encourage them to start investing in AI, in remote sensing for urban infrastructure monitoring, sustainability?
So I would say my one recommendation is to have an open mind and recognize the value in going where the world is going. So it's no secret the world is going towards AI. Everybody uses ChatGPT or Copilot, Gemini, all the tools out there being used, and it's not for no reason. So there's definitely value in going in the direction that the world is going. And it's not about just adapting, the latest technology. It's about staying relevant and staying resilient as the expectations and challenges that, cities and urban environments are facing change and continue to rise. That would be.
What you say reminds me of the picture, if you're not the leading dog, the scenery never changes.
Yeah. Yeah.
Brian?
So here would be my crazy recommendation. I think that every city, depending on their size, every city should have a GIS specialist on their team. I feel like the future is you need to have people in your city understanding how satellite data can help them, understanding how maybe AI and cloud computing works. And if you have a GIS specialist or someone that understands programming and GIS, that is an incredible asset for a city moving into the future. It's not that that person has to solve all the problems, but to be aware of what's out there. So if I was a GIS specialist in a city and, I could contact Jacquie and say, hey, we've got a leak problem, but I know a little bit about satellite data can contribute to that. Now that city is going to have a little bit more knowledge and the ability to reach out to the right people to help solve the problems for the city. Whereas if there's no GIS specialists on a city's as a part of their team, they're going to be very scared and reluctant to use the data. So that's my recommendation. Thanks.
Thank you. Fifam, last but not least.
Yes, it will be good to have a GIS specialist everywhere. It's true, the things will be easier. But anyway, so let's say that our recommendation will be more to give it a try. Let's say we usually define also pilot project. We can consider an infrastructure, critical infrastructure, a bridge, area prone to subsidence that are known to move, where we can make some analysis and see what are the benefits, how much it could be good to have historical information to make scenarios for the future and being proactive, and how this could help in cost saving and enhance safety. So that's all.
Thank you. Yes, I would say that my recommendation, if anybody asks,
It's your recommendation, Daphné.
We spoke a lot about educating the market, and we also spoke about AI explainability. So it's our job, our role to provide enough information, enough transparency for the public to start investing in AI, in remote sensing, and to maybe start with small projects that will bring fast wins, like fast results very easily, and to convince a broader audience afterwards. I think that's it for me. Hubert, you want to say a word?
Sure. Thanks a lot, really, to our amazing panelists. Thanks for this fascinating conversation, Brian, Jacquie, Fifamè. like it was really amazing to better understand the capability of AI application, actually remote sensing for urban sustainability, also in a very open way to discuss the challenges of this technology on capacity building, on explainability, but also some opportunities, technological, commercial opportunities. So really, thanks a lot for sharing those insights. Thanks also to Daphné for amazingly moderating this fascinating session. And that's already the end of this Urban AI conversation. It was really a great pleasure of having you. Thanks to all of you also to attending this webinar. The recording will be available very soon on our YouTube channel. Just share the link in the comments, and an article dedicated to this topic and this webinar will be published on Urban AI Medium next week. Thanks everyone, and take care.
Thanks you.
Thanks to you.
Thank you.
Thanks all. Thank
Thank
you.
you.
Bye-bye.